What's up, recappers? Ellis here with another construction fail. Reality capture could have bailed out. Maybe. We make no promises, but just love to wonder. Be sure to check the latest one we did on the Leaning Towers of Santos, Brazil, which collectively make Pisa look like the Space Needle. Today, we're heeding the collapse of Puerto Rico's famed Arecibo Observatory, a story packed with James Bond lore that proves even the mightiest of alien hunting dishes can fall victim to the most terrestrial of problems. Good old-fashioned cable failure. Oh, and possibly its very own radio waves. Yeah, more on that in a sec. So, the year's 2020, known to many as the Great Toilet Paper Depression. For 57 years, the Arecibo Observatory had been Earth's premier celestial eavesdropping device and a common movie set, home to James Bond chases in GoldenEye, Jodie Foster chatting up aliens in Contact, and a resume that reads like a greatest hits of modern science. Confirming the existence of gravitational waves, winning a Nobel Prize for the discovery of the first binary pulsar, finding the first planets ever detected outside our solar system, mapping ice on Mercury, and sending humanity's first deliberate, "Hey aliens, where you at?" message. The most powerful broadcast ever beamed into space, aimed at a star cluster 21,000 light years away. But on December 1st, 2020, this 900-ton marvel decided to do its best meteor impression and came crashing down faster than you can say ET 3D model home. Thankfully, no injuries were sustained. Bit of a miracle given the scale of destruction, but the catastrophe was years in the making, meaning while Arecibo was busy searching for signs of little green entities, it was missing some pretty big signs right here on Earth. The culprit was a sneaky little process called Zinc creep. No, it's not a new dance move or a Marvel villain who enjoyed a fortified immune system and weirding out women. It's the gradual deformation of zinc used to anchor the steel cables supporting the telescope's massive 900-ton receiver platform. Over time, these cables began slipping out of their sockets. Cut to September 20th, 2017, when Hurricane Maria decided to crash the party with winds between 105 and 118 miles per hour, the highest structural stress those cables had endured since opening day in 1963. And you thought Bad Bunny was a Puerto Rican force. The dish somehow survived, and post-storm inspections gave it a passing grade. A little dented, maybe, but still ready to party with the cosmos. Spoiler alert, that optimism aged about as well as 007 taking a vow of celibacy. By 2019, before any cable had fully snapped, staff had actually documented key cables slipping out of their sockets by as much as 1.5 inches. The acceptable maximum? 0.5 inches. So we're talking 3 times over the limit and no alarm bells. And then 2020 hits. August 10th, the first auxiliary cable pulled out of its socket at less than half its design load. That cable was only 23 years old. On November 6th, a main cable failed. The NSF announced plans to decommission the telescope before things got worse. They did not get that chance. On December 1st, the remaining support cables from one tower failed in rapid succession. The 900-ton platform dropped straight into the dish 400 feet below. The support towers sheared, and decades of discovery ended in about 3 seconds of drone footage. A fate sealed quicker than that alien chestburster scene. Now here's the wildest twist the official report uncovered. Investigators couldn't fully explain why Arecibo's zinc crept so much faster than anywhere else in a century of use. The leading hypothesis? The telescope's own powerful transmitters may have induced low-level electrical currents in the metal cables over decades. This is a process called electroplasticity, slowly softening the zinc from the inside out. The most powerful radio telescope ever built may have been quietly destroying itself with its own broadcasts. Ha! The cosmos giveth, the cosmos taketh. Cleanup alone ran tens of millions. A Nobel Prize winning, planet finding, alien messaging, bond hosting institution was gone, with no replacement to this day. Now, lesson time, kiddos. Here's the dish on reality capture as disaster mitigation or even prevention. When it comes to maintaining massive scientific instruments, maybe it would behoove us to pay a little more attention to the nuts and bolts, or in this case, the zinc and cables holding everything together. And there is no better toolkit for such tasks than reality capture united with modern monitoring technology. I mean, just imagine if we had laser scanning and photogrammetry, regularly building millimeter accurate 3D models of those cable sockets, catching measurable zinc deformation before it became a full-blown cable mutiny. Remember, by 2019, those cables had slipped 1.5 inches. A reality capture scan ain't likely to miss that. The data was there, but what was missing was a system to make it impossible to ignore. Calling all drones, reaching every nook and cranny human eyes couldn't access on a 500-foot tall structure above a natural sinkhole. Is that a corroded socket or just a very shiny space rock? Enhance! Remember, the post-Maria inspections cleared the structure, but drones with thermal and multispectral imaging may have told a very different story. Digital twins, anybody? That could have ingested that drone and scan data in near real time, flagging anomalies against the original engineering specs automatically. A twin running structural analysis on the 2019 cable slip data would have modeled exactly what load was now being transferred to the outer wires and what the domino failure timeline looked like. Engineers wouldn't have needed to recognize that threat manually because the model would have bloody screamed it at them like Q when James ruins a new toy. If you know, you know. Then there's robotic inspection systems, crawlers, tethered bots, physically traversing cables and towers on a regular schedule, taking high-res images and force measurements at the socket connections themselves. No ladders, no weather windows, no human risk. Just consistent, safe data over time. Finally, treat AI like quarterly earnings reports and put it everywhere. So while these tech marvels may not have saved Arecibo from its ultimate fate, after all, the electromagnetic self-destruction hypothesis is genuinely unprecedented and not something any inspection could have predicted. They could have absolutely caught the symptoms early enough to act. Before things went from 007 to the zinc was slipping, the cables were failing, the data existed. What failed was the system around it. So here's hoping the next generation of scientists and engineers remembers to always check their cables and build the tools that make the checking automatic. Because in the grand cosmic dance, sometimes it's not the solar flares you need to watch out for. It's the zinc.